Hello everyone, welcome back to our channel. So today we are going to discuss another problem from the CSES problem set, that is list movements. So let's understand what the problem is saying and then let's jump into the solution. So the problem is saying you are given a list containing any integers and you have to remove the elements from the list at given position and remove the removed elements. Okay, so these are the size, list and position. Okay. So let's understand what the problem is saying. So the problem is saying we have 2, 6, 1, 4, 2. We have an array which is 2, 6, 1, 4, 2. And now we have to remove the elements on the positions 3, 1, 3, double 1. Okay. So now we have to remove the elements 3 and 3, double 1. So let's have our thing. So we need to remove the elements at the third position. So at the third position, element 1, 2, and 3. So we will have to remove the element 1. So after, and we will store it in the output array. So output will be 1. Now our array would be changed after removing these elements to 2, 6, 4 and 2. Now we have to remove the first element. The first element removed will be 2. So we will have to put 2. And now our array will change to 6, 4 and 2. Now we have to remove the third element, which would again be 2. So we will output 2. And our array will change to 6, 4. Now remove the first element, that would be 6. Then we will remove the first element, that would be 4. So it will be 6, 4. So is this the output here? So this is what the problem is saying. When we remove a particular element, our array is also updating, and then we have to remove the element from the updated array. So now let's see how we can actually solve this problem. Okay. So the first approach that comes to our mind is the brute force approach. The first approach is the brute force approach. So this approach is actually like saying we have an array. After removing the pith element, we will update the array. We'll update the array and then you will again remove the pjth element and so on. So this would actually be a very costly operation as for each removal would take less than big of one time, because you know the index and searching in the array for index is over one time. But then updating the array would actually cost you around big of n time approx, because then you have to reposition all the ith elements from this index to the last index, in worst case which you go to of n, and then you are traversing this for all this pi elements, which will be v of n. So this would actually land up to v of n square, and this approach would not be acceptable as for the time complexity, because n is a very large number. Now let's understand how we can actually solve this with an optimized approach. Now you know that we are like learning segment trees in this section. So let's see how we can actually solve this with an example of a segment tree. How we can solve this with a segment tree. So we have an array 2, 6, 1, 4, 2. Now we know that in a segment tree there is a tree node which actually store some of value related to its children, or we can say a subproblem, right? So how about if I say for every tree node of I, if I know how many active elements are there, if we go in this line, how many active elements? Initially we have 5 active elements, 2, 6, 1, 4, 2. We have the 5 active elements. After removing 1, we would be having 4 active elements and the active elements count would be going to reduce. Now what if I say the elements that we are actually going to remove is not exactly removing from the tree, but it's actually saying giving me the kth active element. So wouldn't it be the same as removing the elements and getting the elements that are actually being removed? Let's understand this with an example. 2, 6, 1, 4, 2, 1, 3, 3, 1, 3, 3, 1, 3, 2. So all these are initially active. So if I remove the, let's find the third active element. The third active element would be 1. So I'll output 1. And I'll then mark the active for this as to be 0. Now the active elements would be 2, 6, 4 and 2. And now we will be finding the first active element from these elements, that would be 2. So we will be outputting 2. Now we will mark this as 0, like this would be a non-active element. Now 6, 4, 2 will be the active elements. And for this 3, the third active element would be 2. So we will output 2, 2. This would be marked to 0. Then the first active element would be 6. And after that, our first active element would be 4. So 6 and 4. So this is how we will be approaching in the sense of active elements to find which elements are being removed in the order. So this approach would actually overspend time to traverse like through these elements, and for each element we would be taking log n time to find the kth active element. So this is the approach would be O of n log n, in which we would be using the segment trees. So now let's understand the code what we have done. So there's a minor change just in the code. So for every tree node, now we are actually storing the count of active elements in the children of that particular node. So count would be tree node of left child plus the tree node of right child. And for every query, let's suppose we need to find the kth active element. So for kth active element, we're finding the left side. If the left side is greater than the k, then we know that kth active element will lie in the left side only. So we would be traversing the left side. Else we would be traversing the right side with the remaining element. That is the kth minus the left max. Now we need to update the tree. So at the time of update, a u would be 0. So I will be updating my tree node to be 0. When we find out that we have reached that particular node which needs to be updated. And this is how our code would look like. So we will take the inputs, and for every index I will be finding the kth active element, outputting the index that we have got, and then updating my segment tree. Now let's try to submit this solution once. Choose CP, which file main.cpp. Load. Import where the error. Okay, so I guess I found the error that we have made. Okay, so the error that we have actually made is we need to initialize our tree nodes as to be 1, like at the time of the build, because initially all the nodes are active. So now let's try to submit this once, this change. I guess now this should get accepted. Yeah, so this get accepted. There was just a small change. So our initially the tree node should be initialized to 1 because of the active nodes, and rest of the solution remains same. So this is how we actually solve this list removal problems. And I guess if you like the solution, please do share and subscribe the channel. Thank you.